probability of where it's going to be
very serious
as you get a better
asteroid
idea of
condition.
orbit. So this is why it's
2032,
probability.
danger
And I imagine
to
we'll
life,
become even more
Earth,
over time as well, because we get more and more information.
climate change, UK 2025.
So we've got a period now where we're looking at it. It's travelling away from the Earth right now, so it's getting fainter and fainter. But in 4 years' time, it will pass by us again, and we will study it again in much greater detail as it passes by in 4 years' time. And that will prepare us for the 4 years after that, where there is this 2.3% chance of it hitting the Earth.
So let's talk about preparing. Let's start with the bad stuff first. If, and it is a big if, it hits, what does it do? How powerful is it?
Okay, so the
Not
nature of asteroids
danger at extinction level,
it's
surely.
It's not an if, it's a when. So the Earth has been hit by these many times in the past. Most famously, of course, 66 million years ago, we were hit by a rock that was sort of kilometres in diameter that wiped out the dinosaurs. I believe. So this is a much smaller rock. We're talking about 60 metres in diameter. So that's about the size of the wingspan of a jumbo jet.
Right.
So when that lands, it's still quite significant. The blast will be comparable to 500 times the strength of the Hiroshima atomic bomb.
500?
Yeah, so this is a large impact. This would be the most significant impact in 100 years if it was to occur. But even if it hits the Earth, of course, much of the Earth is water, is uninhabited. So that event back in 1908, which was the most significant one in 100 years,
Wow.
that hit in the middle of Siberia. So there was no damage to human infrastructure. It flattened 80 million trees.
Wow.
So that's the type of impact we're talking about. But the great advantage is that, there's two things. So first of all, we're tracking things a long time in advance. So we were talking about the kind of disaster movies in the past, things like Armageddon with Bruce Willis and that sort of thing. We see it coming towards the Earth and there's only a week's notice. What's really changed in the past 30 years is we now have much greater warning about these things.
But you missed those asteroids that hit Russia years and years ago.
The telescope technology
You caught it by surprise.
Capability has really improved. But also
You
there's been a lot of
NASA
financial
scientists.
investment, a lot of political will in tracking and finding these things. Right. And when you find them much further in advance, you have more chance to do something about it. In 2023, NASA tested something called a DART, the Double Asteroid Redirection Mission. And essentially, this is very simple. They took a satellite and they slammed it into the side of an asteroid as hard as they could in an attempt to divert it. And that was very successful. So it's the first time this has been tried. It was trialled essentially for precisely the situation where something was going to hit the Earth.
Was that asteroid as big as this one?
It's comparable in terms of size. But here's the key thing. If you have the early warning, if you know years in advance, you don't need to give it as big a nudge in order for it to miss the Earth. If we have 1 day's warning, you have to give it a really big shove for it to miss the Earth. If you have 4 years, relatively tiny for it to miss the Earth 4 years later. So the combination of our sort of early detection technology and the fact that we tested a redirection asteroid means for the first time in human history, we do have a chance to do something about it when this happens. If it's not this one, it will be a rock in the future that is going to hit the Earth and potentially cause some damage.
How big was the rock that hit the Earth that destroyed the dinosaurs?
So here the diameter is kilometres across. So this is extremely large. So what's interesting is, again, in the past 30 years, due to our sort of detection technology, we now think we basically know about every rock of that size near the Earth. So we think we're something like 99% complete. So
wow.
Really big stuff. We know where it all is. We can track it and predict where it's going to be.
Yeah.
These smaller ones,
Can't get all of them, though.
Tens to hundreds of meters across. That's where the interest is now. And this becomes a lot harder because they're smaller, they're fainter, so we only see them when they're very close.
Yes, indeed.
So fascinating. We're all fascinated by this, aren't we? And we said it's the stuff of Hollywood science fiction, but actually
it's not.
It could be real.
Yeah.
It's very real. But it's a huge collaborative effort to detect these things because we detect it when it passes by the Earth. It's very small. We only see it when it's close. So you need telescopes and astronomers all the way around the Earth. Yeah. So as the Earth rotates and the night passes over, they can use a different telescope to observe it, to track it, and orbit. So it's an example of collaborative science. So much of science is a worldwide endeavour, and it's a human problem that we solve by working together.
Teamwork makes the dream.
Nice to see you. Thank you.
I hope you like this video. This is Sky's channel on Sign Edge Evans. But of course, be with you always. Let's spot the needs in a minute. The needs to this is my friend's Biking Jimbo. Every Friday at 10 a.m. to 12 p.m. on the Surrey Hill ratio, live 1 week and one recorded show every Friday. And you name it. Yeah, it's 3 to 5 p.m. Listen to my friend Shane live through the years every Friday, live at 10 to 12 p.m. with Cindy Lou on Surrey Hill Radio, and this is my friend John on Lara's show every Sunday at 9 to 12, and live on the Wogan show on Lara's show every Sunday at 9 to 12 p.m. This is Squash on St. John's, my bit.